Hi, my name is Greg Whiting, and I'm here to talk to you about dirt. At the turn of the 20th century, in his inaugural address to the British Association for the Advancement of Science, Sir William Crookes warned a world then of about 1.5 billion people of a coming disaster. There simply wasn't enough nitrogen in soil and available from natural sources to feed the growing population. People were going to starve, and a solution needed to be found. About a decade later, German chemists Fritz Haber and Karl Bosch came up with a solution to this problem. By taking nitrogen from the air and mixing it with hydrogen at high pressure and exposing it to heat and to iron, they were able to convert that nitrogen from the air into ammonia. Today, the Haber-Bosch process is mostly used to create chemical fertilizers, and it's extremely important to life on Earth. There are billions of people today that we wouldn't be able to feed without it. So there are also some drawbacks to this really important and incredibly successful technology. Fertilizer can be expensive for some farmers. Its excess use can cause soil and environmental degradation. And it uses lots of energy, tons of energy. In fact, it uses about 1% of the total energy we use in the world. So you can see that it's important that we carefully manage nitrogen in soil. But it's not just nitrogen. There are other inputs that we want to control too. Things like water or other nutrients. And we also want to manage the amount of carbon in the soil or even the soil microbiome. So understanding what's happening in soils in real time would be really useful in order to optimize the amounts and types of inputs we add, to grow food even more efficiently, and to ensure overall soil and environmental health. This is particularly a concern with our large and growing population and with a changing climate where growers are going to have to adapt to new environmental conditions. However, getting a good picture of what's going on in soil in real time can be a challenge. The kinds of things we want to measure can vary a lot from place to place. And if we used regular electronics to do this, it might not be practical. They might get in the way of farming operations or make lots of waste or require a ton of maintenance. My research group at the University of Colorado Boulder is working with collaborators in the US and around the world in order to develop new instruments that can be used by soil scientists or agronomists or farmers in order to better understand and manage the soils that they work with. We imagine a future where, without significant extra work or additional cost, a grower would be able to see a map of the contents of their soil in real time, helping them to better manage the inputs that they put into it. And ultimately to also receive feedback on the things that they're putting into the soil after they do it, allowing them more precise control. In order to achieve this goal, we need to make devices that are not only accurate, but also inexpensive, so that we can use lots of them to figure out what's happening at different places in the field. Since we need a lot, they need to be maintenance-free, they need to not get in the way of farming operations, and they really need to be generally compatible with the environment that they're in. In order to do this, we manufacture our sensors using printing techniques. This allows us to make large amounts economically that can be used to cover very large areas in a field. And what's really cool is that we can use unusual materials to do this. Sometimes we build our sensors out of biodegradable materials. This allows them to be put on a field and operate for a while, and then when they're no longer needed, they simply degrade away. And for the next growing season, we can apply new ones. In addition, we can even take these sensors and implant them directly into plants, so we can see what's happening inside the plant itself as well. Dirt is something that we're all familiar with, and it's everywhere. And it may not be something that we think about all the time, but it's critical to life on Earth. In my lab, we're working on creating new instruments to better understand the dynamic changes that are happening in soil. And we're super excited to be working with creative farmers and scientists to help to ensure that soils, the environment, and people can remain healthy and safe for a long time into the future.